So pressure effect. Generally, higher pressure, as we mentioned, higher pressure leads to higher packing density. Very natural. But it would saturate at random close packing, kind of random close packing. Here we are showing the relative density experiment versus the compaction pressure. Probably for this one, he's using a very good tool so that it allows him to go to 600 megapascal. Okay, so initially the density increases quickly. Makes sense, right? Initially it increases quickly because remember the previous plot we are plotting on a log scale, right? Here we are plotting in linear scale. So initially it goes very quickly and then slows down, but eventually it's going to kind of more or less saturate at around 65, something like that. You cannot go too higher than this. They're going to slow down. And then what happens as you go to higher and higher pressure is there are different modes as we illustrated here. We see clearly there's a gap or open space. And then you can imagine we may have so-called rearrangement, pushing other particles around while each of them maintain its shape or form. That's one possibility happening, probably at a relatively lower pressure. As the pressure goes higher and higher, depending on the material property, if it's more plastic, I may force it to fit in, right, between the neighboring one, if the neighboring are harder or whatever. Or if it's more brittle, I may force them to crack. But at the same time, I fill in at least partially. Make sense? These are just the different modes that you can imagine what is happening at micro scale, at small scale. Different process may occur as pressure is applied, including, as we said, rearrangement, deformation or change of shape, or fracture, larger particles coming apart to smaller particles. Okay?